When undertaking electrical load calculations, the instructions provided are paramount. If explicitly directed not to include the house load or laundry load in the calculation, then the standard 3 volt amps per square foot rule should not be applied. The 3 volt amps per square foot rule is a general estimation method that accounts for the overall electrical demand of a dwelling, including general lighting, receptacle outlets, and small appliance circuits which are considered part of the general house load, as well as dedicated laundry circuits. However, specific scenarios, particularly in examination settings or specialized calculations, may require a more granular approach where certain loads are intentionally excluded. This is done to assess the impact of specific appliances or equipment in the overall electrical system, isolating them from the baseline house load. When a question or calculation specifies the exclusion of house load and laundry load, it is crucial to adhere strictly to these instructions. Instead of applying the 3 volt amps per square foot rule, you must focus solely on the loads that are explicitly listed, such as air conditioning, garbage disposal, electric range, and other specific appliances. To perform the calculation correctly, firstly, identify all the listed appliances and their respective volt, ampere, or wattage ratings. These ratings are typically found on the appliance nameplates or in the provided data. Secondly, for appliances with volt-ampere ratings, use those values directly in the calculation. For appliances with wattage ratings, convert them to volt-amperes using the formula volt-amperes equals watts divided by power factor. If the power factor is not provided, it is common practice to assume a power factor of 0.8 for general-purpose loads. However, it is important to note that certain appliances like electric motors may have different power factors. Thirdly, apply any applicable demand factors to the appliances based on the National Electrical Code or local electrical codes. Demand factors are reduction percentages that account for the fact that not all appliances will be operating at their maximum load simultaneously. For example, electric ranges are subject to demand factors as outlined in NEC Table 220.55, which allows for a reduced load calculation based on the number of ranges. Fourthly, sum up the volt-ampere values of all the included appliances after applying the appropriate demand factors. This will give you the total calculated load, excluding the house load and laundry load as instructed. It's important to remember that the purpose of excluding the house load and laundry load is to isolate the impact of specific appliances on the electrical system. This type of calculation might be used to determine the required size of a feeder or service for a specific set of equipment, or to assess the capacity of an existing electrical system to handle the addition of new appliances. In contrast, a complete load calculation including the 3 volt amps per square foot rule provides a comprehensive assessment of the total electrical demand of a dwelling, which is necessary for sizing the service entrance, feeders, and overcurrent protection devices. When encountering these types of questions on an examination, pay close attention to the wording of the question and the instructions provided. If the question explicitly states to exclude the house load and laundry load, do not include the 3 volt amps per square foot rule in your calculation. Instead, focus solely on the explicitly listed appliances and their corresponding volt ampere or wattage ratings. To further illustrate this concept, let's consider an example. Suppose you are asked to calculate the electrical load for a dwelling, excluding the house load and laundry load. The following appliances are listed: a 12,000 volt amp air conditioner, a 900 volt amp garbage disposal, and a 10,000 watt electric range. Assume the range's demand factor can be applied. Firstly, the air conditioner is already given in volt amperes as 12,000 volt amps. Secondly, the garbage disposal is also provided in volt amperes as 900 volt amps. Thirdly, for the electric range, we need to apply the demand factor from NEC Table 220.55. Assuming this is a single range, the demand factor is 8 kilowatts, or 8,000 volt amps. Fourthly, now we sum up the volt ampere values of all the included appliances. 12,000 volt amps plus 900 volt amps plus 8,000 volt amps equals 20,900 volt amps. Therefore, the total calculated load, excluding the house load and laundry load, is 20,900 volt amps. This value represents the combined electrical demand of the air conditioner, garbage disposal, and electric range, without considering the general lighting, receptacle outlets, and small appliance circuits that would typically be included in the house load. In contrast, if you were to include the house load using the 3 volt amps per square foot rule, you would need to multiply the square footage of the dwelling by 3 to obtain the volt ampere value for the general lighting and receptacle outlets. You would also need to add a separate volt ampere value for the laundry circuit, typically 1500 volt amps as per NEC 220.52b. These values would then be added to the appliance loads to arrive at the total calculated load. However, in this specific scenario, you are instructed to exclude those loads from the calculation, so they should not be included. Understanding the nuances of electrical load calculations is essential for electrical professionals and anyone involved in the design, installation, or inspection of electrical systems. By carefully following the instructions provided in each calculation and applying the appropriate rules and demand factors, you can ensure accurate and safe electrical system designs. Remember, always consult the latest edition of the National Electrical Code and any applicable local electrical codes for the most up-to-date requirements and guidelines.